Let's put together several concepts that we have learned to do an analysis of the relationship of a categorical and quantitative variable. I'm going to use the 2014 state education data for this example. Specifically, I'm going to look at the relationship of teacher salary to region of the country. I have one additional objective for this video lesson. I'm going to show you some of the small trouble spots that can introduce themselves when we're trying to construct a graph with research data. My objective is to show you simple tricks for addressing these trouble spots. I'm going to start by loading my R data file that contains the state educ object, which in turn contains the data. Let's get a box plot. This is pretty good. A quick glance tells me that there is a relationship of salary and region because the box plots are not all the same for every region. I see differences in both center and variability of the salary distributions when we look at them separately by region. There are, however, some small problems. Some of the region names are missing along the axis. One solution that sometimes works is to simply increase the size of the plot window in RStudio. Look at that. That fixed the problem. We could leave it at that, but someday you won't be happy with the dimensions when you export your graph. Also, you will almost certainly encounter a situation where expanding the graph still doesn't fix the problem. Let me put the plot window back to its original size and look for other possible solutions for dealing with the axis labeling issue. The first solution is to include an additional parameter in the boxplot function. That parameter is LAS. The purpose of LAS is to tell R how we want to orient our category and quantity labels relative to our axes. The default is to put the labels parallel with the axes, as they are in this box plot. If I change it so that LAS equals 2, R will put the labels perpendicular to the axes. Let's do it. That fixed one problem, but obviously we're not ready to send this to press. The text is so long it gets cut off at the margins. Everyone who creates graphics with R should learn how to adjust the margins, so let me show you how. Here's the function that I'm going to use. The par function is used to set graphical parameters. As you may have guessed, par is short for parameter. The parameter I want to set is the margin, which is abbreviated MAR. R refers to margin distances as lines. I'm going to set the plotting region on the four sides of the graph to 9 lines away from the edge, 4.1 lines away from the edge, another 4.1 lines, and 2.1 lines. You have superpowers if you aren't wondering by now where I came up with those numbers. These values are for the 4 margins in this order: bottom, left, top, and right. The default values that R uses if you don't specify the margin are 5.1, 4.1, 4.1, and 2.1. So if you compare the default values with my numbers, I've only changed one margin, and that is for the bottom edge. I changed the value from the default of 5.1 to 9. When I run the box plot function, the only margin that should change is the bottom margin. Let's try it. Yep, that pushed the margin up so that now our labels show. It looks like I'm going to need more room on the left margin too, so I'm going to change the second value, which is for the left margin, from 4.1 to 6. Then I'll run the box plot command again. Okay, we're getting there, but we have a little more tinkering to do before leaving the margin command. Let me tell you that there's no shame in just trying different values for the margin parameter, then running your graph function, then trying more values until you have the margins where you want. That's how I came up with my values of 9 and 6 for the bottom and left margins. Trial and error. Now we're going to use the mtext function. This abbreviation stands for margin text. First, I'm going to create a box plot without labeling the variables for each axis. So I removed those parameters from the box plot function. I'm going to write the text regions on side 1 at line 3. Remember for the margin parameter that the order of values was bottom, left, top, and right. The bottom is listed first, which is why I'm telling the mtext function that I want to write region in the first margin. That's the bottom margin. We know that the margin includes 9 lines because I set it that way, so I'm going to try writing my text 3 lines down into the margin. Here goes. That didn't work so well. It wrote the text in just about the same spot where the regions label was before. So let me try it with 7 lines. That's better. I'm going to run the box plot function and the correct mtext function again so that we can erase our first try with mtext and use the values we want to keep. I need to label the vertical axis as well, so I'm going to do that by using side 2, the left margin. Let's try putting 4 lines into the margin. Okay, that works. We've leveled out all the little bumps in the road and we could stop here. But while I'm on a roll, let me show you another useful function. This is another graphical parameter, so I'm going to use the par function again, but this time with the parameter cex.axis. The default for this is 1, but I'm going to change it to 0.7. What this does is change the size of our category and quantity labels to 0.7 or 70% of what they were before. Let's try it. That works so well that I really don't need all that margin space. I'm going to make a few adjustments. Look at the script and see if you can find the changes that I made. An important note. When you use the par function to set graphical parameters, Those will stay set with those values for all future graphs until you reset them to their default or some other value, or until you begin a new R session. I'm pleased with what I have now, but before we leave graph construction, let me leave you with one more consideration. Frequently, when dealing with large or small numbers, we can make it easier on our readers by changing the unit of measurement. Instead of using unit of dollars, what if we change the unit of measurement to thousands of dollars? I can accomplish this by dividing the salary by 1,000. Here's what it looks like. You must admit the numbers on that vertical axis are less intimidating. Notice that you must remember to change your axis label to reflect this new unit of measurement. Okay, we've now arrived at a nice graph that shows the relationship of region to salary. I invite you to study this on your own. For starters, the graph displays lower salaries in the Plains states, the Rocky Mountain states, the Southeast, and the Southwest, than in the Far West, Great Lakes, Mideast, and New England. The regions with higher salaries are also more variable across the states in the region than in regions with lower salaries. Let's finish this off by obtaining the 5-number summaries, the means, and standard deviations for each region. If we export our graph and put these statistics into a nice table, we will be ready to write some narrative and create a report about the relationship of teacher salaries to regions of the country.